Good evening and welcome to all of you again. Session number 8 for vectors. So we will start with the discussion today of the doubts from worksheet 5. So let's start with question number 2, which is the first request I have received for discussion. That's a question 1 also. Okay, Hitanshu has sent question 1, so we'll in fact start with question 1. Question 1 is actually from the previous concept. It's a very simple thing. The vector E is given to us as I cap minus root 3 j cap, and we have to find the angle with respect to the positive x-axis. So what we do is we just understand from the components of the vector that if you were to draw this vector with respect to your xy axis, its angle would lie in the 4th quadrant, because the y component is negative and the x component is positive. So this particular vector would have, if you draw it from the origin, this particular vector would, okay, Hitanshu, so 1 is clear, I think, right? Okay, so anyway, I'll just complete the question. So it would be something like this, right? Where this is minus root 3 and this is 1. So you can see this is theta. So theta is equal to, or tan theta is equal to minus root 3 perpendicular upon hypotenuse, and it's in quadrant 4. So theta will become minus of 60 degrees. Okay. Or you can also say that theta is equal to 300 degrees. You can express it as positive of 300 or minus of 60. Okay. Right, so this was the first question. In case anybody has a doubt in it, you can just quickly understand this. Moving on to the second question. The second question is a more current type of question. It is based on the application of dot product. So how do we find the angle between two vectors given to us in component form? Okay, let's understand that. So given two vectors E and B in component notation, that is I cap j cap notation, to find the angle between them, let's say the angle is theta between them, we just use the definition of dot product. Since A dot B is equal to AB cos theta by definition, okay, therefore cos theta becomes A dot B divided by product of the magnitudes, or we can say that theta is cos inverse of the dot product divided by the product of the magnitudes. And we know how to find dot product when vectors are given in component form. So for example, in this particular question, vector A is given to us as I cap plus j cap, and vector B is given as 2I cap plus 2k cap. Okay. So you can straight away see that the magnitude of vector A is root 2. And you can see the magnitude of vector B is 2 root 2. Okay. And we can also see that A dot B is 1 into 2 plus 1 into 0 plus 0 into 2. Okay. Or in other words, it is Ex bx plus Ey by plus Ez bz. This is the formula. Okay. So applying that formula now, we can see that this becomes 2. E dot B is equal to 2. So therefore, cos theta, which is E dot B divided by the product of the magnitudes A into B, that becomes 2 divided by magnitude of A was root 2, and this was this much. Okay. So it becomes 1 by 2 So theta is cos inverse of half. So theta becomes 60 degrees. So interestingly, the answer of this first and second question both are 60 degrees, but due to different reasons, of course. Okay. So you can just make a note of the whole concept only first, and then come to this particular example. This concept here, that the easiest way to find the angle between two vectors when they are given in component notation is to use the dot product definition. This is like the inverse of the dot product definition. Yeah, please send me any difficulty or doubt you have over the text chat. If anybody has a difficulty or something is not clear in the question, please send me a message. I'll respond. Okay, next we are going to move on to question 3. And the hint to you for question 3 is it's a very similar application. Like we found the angle over here between the two vectors. There, one of the vectors is unknown, but we have to use whatever we know about dot product to find the condition for them to be perpendicular. So we discussed last time, what is the condition for two vectors to be perpendicular? Their dot product should be how much? 0? Yes, very good. So you make use of that. Okay, that is correct, Anish. Whenever two vectors are perpendicular, their scalar product or dot product must be 0. So that is the concept you use in the third question. I'll just verify your answer, Shikhar. Okay. I don't remember the answer, but it seems correct. So you will get 2 minus 16 plus 2c should be 0. Triangle law, but how you will apply triangle law here, because अच्छा, E plus B करके वैसे. You can do that also. That's also correct. You can do that. It will just become a little lengthy if you do by triangle law. You can do that also. I'll show you that method also. It's interesting. But the easier method is to check the condition for vectors A and B to be perpendicular. The easy method is that A dot B should be 0. Okay, because cos 90 is 0. You know that. So from that. So here vector E is given to us as, what is the components? C. C minus 4 and plus 2. So C I cap minus 4 J cap plus 2 K cap. And vector B also has one component unknown, but in terms of the same variable C. And vector B is given to us as 2, 4, C. So 2 I cap plus 4 J cap plus C K cap. The easy way here is that if E is perpendicular to B, then A dot B should be 0. So we'll just apply the condition on C now for that to happen. So as you can see, 2C minus 16 plus 2C. This whole thing should be 0. Or C should be 4. So that was the correct answer. 2 plus 2C should be equal to 16. Or you can say that C should be equal to 4. Okay. You can also do it by the triangle law method. Okay, but that will just be a little bit more lengthy in comparison. Okay, which is why I'm saying that from now on you should remember the easiest way to check the condition for two vectors to be perpendicular, especially when given the vectors are given in component form. Okay, is that this dot product should be 0. If we use triangle law, then what should happen? If the vectors are perpendicular, then E plus B should have a magnitude of root of A square plus B square. You can do that also, but it's a little more lengthy. I'll just explain to you how that works. So hope this method is clear to all of you. Now, alternately, you can also do this, like Rahel here has tried this alternate method. If E and B is are perpendicular, then magnitude of a plus b should be equal to root of a square plus b square. Okay. So here let's just take the values and understand from above. From these values, e plus b क्या हो जाएगा? Just do the sum of the two vectors. So e plus b you will see is c plus 2 I cap. Okay. Then minus 4 plus 4, so 0 j cap plus again 2 plus c k cap. Okay. So from this we'll know that magnitude of a plus c, sorry, magnitude of e plus b कितना हो जाएगा? It will be square root of c plus 2 whole square plus c plus 2 whole square. So that is c plus 2 the whole thing into root 2. Okay. Now you can also see from this that what is the magnitude of the vector e itself. You can see above. The magnitude of the vector e is root of c square plus 4 square plus 2 square. So that is root of c square plus 20. Okay. And magnitude of b is also the same, 2 square plus 4 square plus c square. So that is c square plus 20. Now you apply this condition here. Okay. Therefore, magnitude of a plus b is equal to root of a square plus b square. This implies that c plus 2 whole thing into root 2 should be equal to square root of c square plus 20 plus c square plus 20. Okay. So now next to solve this, we can square both the sides. So squaring both the sides, we will get c plus 2 whole square into 2 should be equal to 2 times c square plus 40. Okay. So c square plus 20c plus 4. Oh, sorry, c square plus 4c plus 4 into 2 should be equal to 2 times c square plus 40. Right, so we will get that. So we get 4c is equal to how much? Twenty minus 4. So 16. So c is equal to 4. Correct. We get that same. Okay. No, beta, ये 2 से cancel हो जाएगा ना. Next step C. Next step here is that, yeah, this will actually become c square plus 4c plus 4 is equal to c square plus 20 on the other side. So c square can cancel off and this. Okay. So yeah, I mean this is a little bit more lengthy, but you can use this method also. Okay. So the easier way, remember, I mean this is always okay. You can use this method. There's no problem with this, but it's going to take more time. The more convenient method is the dot product method. Okay. So just remember that like a theorem now. That condition for two vectors to be perpendicular, rather than use this condition, use the condition that E dot B should be 0, which is the method we have done above. Okay, so hope this is clear, people. So that was the third question. Now next I have been asked to discuss the fifth question, so we will do that. Okay. I think the fourth question was simple enough. All of you would have got it. Some of the questions in between are like revision questions for you to understand. Just quickly revise steps that we've done previously. Some were based on just what we learned in the last lecture. Okay, so let's come to the fifth question next. So I hope both the methods in this are clear. But as I told you, from now, remember this as the easy method of solving for perpendicular condition. That dot product should be 0. Okay. So fifth question is a logical question. Okay, you have to understand it this way, that question 5, if magnitude of A plus B is greater than magnitude of A minus B, right? That is the condition given, or is it less than? Greater than mod of A minus B. Okay. Then what we can say about the angle between the vectors? So let's understand. So just expand this. So root of A square plus B square plus 2AB cos theta is greater than root of A square plus B square minus 2AB cos theta. So you can square both the sides because both quantities are positive. So one positive quantity is greater than the other, then its square is also greater than the other. Okay, so A square plus B square plus 2AB cos theta is greater than A square plus B square minus 2AB cos theta, which basically will mean that cos theta has to be a positive quantity. 4AB cos theta is greater than 0, which means that obviously A and B are greater than 0 because they are magnitudes of vectors. 4 is also greater than 0, it's a number, positive number. So cos theta has to be greater than 0, which means that theta has to be an acute angle. Okay. That means theta can be anything greater than equal to 0, including 0, but less than 90. Because when theta becomes 90, mod A plus B actually becomes equal to mod A minus B. Okay. So this is also something like an inequality to remember, which you can also remember in this form, that in other words, or you can also understand it this way, that if theta is between 0 and 90, okay, then A plus B has a magnitude greater than A minus B, which is the thing we've just seen. Okay. Also, it's worth remembering that if theta is exactly equal to 90 degrees, then A plus B has a magnitude exactly equal to A minus B. And that magnitude is in fact equal to root of A square plus B square. Okay. And also, if theta is greater than 90 but less than equal to 180 degrees, so obtuse angle, then what happens is that A plus B becomes less than A minus B's magnitude, mod of, okay. So this happens because cos theta is negative, because theta is obtuse. Here this happens because cos theta is 0, because theta is 90 degrees. And here this happens because cos theta is a positive quantity whenever theta is acute. So this is like, in itself, it's an important set of inequalities that are very obvious from triangle law statement, but you should understand this. So you can just make a separate note of this also. So any logical question of this type, you can answer very easily. You just keep mindful of this fact. Okay, we will hope this is clear why this happens. Okay, the explanation is similar to like we've done above. If you expand, then you can see. जब भी cos theta positive होगा क्या होगा? Left hand side will be greater than right hand side. जब भी cos theta 0 होगा, left hand side will be equal to right hand side. So mod A plus B will become equal to mod A minus B. And on the other hand, whenever cos theta is negative, it's the right hand side quantity which will become a larger quantity compared to the left hand side. So mod of A minus B will become larger. So that is the logic of these inequalities. No, theta is not greater than equal to 0, but cos theta is greater than 0. So the correct answer, Shomorup, in this question will become that the angle between them should be acute. Okay, 0 भी 1 होता है ना, cos 0 is 1. So whenever your angle is 0, understood now? So that's why. So it includes 0. The condition for mod a plus b being greater than mod a minus b includes 0, but it doesn't include 90. Because if 90 होगा तो क्या होगा? It will be equal. Mod a plus b will be equal. It will not be greater than mod a minus b. So if I'm saying it is definitely greater than mod of a minus b, then I'm saying that theta is definitely less than 90. Okay, so yes, otherwise scroll up. So you understand this. So let me show the whole thing in detail. Oh, fourth sum, we'll come back to the fourth sum. You can see it in the recording later. Don't worry. Right now, concentrate on the fifth one. Oh, fourth, in fact, I haven't solved because fourth, nobody else asked. So, otherwise, you have a doubt in the fourth question. Yeah, in fourth question, just use triangle law beta. Okay, so I'll explain. Let everybody finish with this, then we'll come to fourth question. In fourth question, you just have to use triangle law. I'll give you a hint. It's simple. Okay, so just to give you an idea of what to do in question 4, it's an easy question, so I'm not solving the whole thing. It is given to us that mod of a plus b plus c is 0. This is given condition. Okay. Also given that mod a is equal to mod b is equal to 10 and theta between a and b, that is equal to 120 degrees. So from that we have to find mod c. How much is the magnitude of c, right? That's what we have to find out in the fourth question. Right. So what you do is you use this. So this thing that is given, it implies that a plus b plus c is a null vector. That's why its magnitude is 0. So that implies that c is equal to minus of the vector sum of a plus b. So that implies that magnitude of c will be equal to magnitude of minus a plus b, which will be nothing but magnitude of a plus b. Okay. That will be nothing but mod of a plus b. Okay. And now just substitute this in the triangle law formula. Okay. So substitute that in that root of that whole formula. Substitute that, you will get the answer. Okay, good. So fifth is done. Now after fifth, the next question people have asked me so far is I think eighth question. Let me just, yeah, question number 8 somebody has asked. So let me go through question 8. So I'm assuming that 6th and 7th all of you have understood how to do. Okay, so in 8th question we have to use the concept that we learned last time of direction cosine. Okay. So I'm just elaborating question 8. What is happening in question 8 is two vectors a and b are given to us, and then we have to find the angle that their sum or that the resultant sum makes with respect to the x-axis. So since they are three-dimensional vectors, a is 4 minus 2 and plus 6. So 4 I cap minus 2 j cap plus 6 k cap, and b is 1 minus 2 minus 3. So I cap minus 2 j cap minus 3 k cap, right? So that is the vectors. Now we have to find the angle that the vector a plus b makes with respect to the x-axis. This is what we have to find. Okay, how much angle it makes with respect to the x-axis. Okay. So, and you can see the answers are given in terms of cos inverse. So we have to use the concept of direction cosine. But for which vector? For this vector. So first let's find out what this a plus b is. So a plus b will be 4 plus 2, 5 I cap -2 -2, so that's -4 j cap, and 3 minus 6, I mean 6 minus 3, so that is +3. So this is the vector which is a plus b, okay, and it has magnitude, you can see, root of 5 square plus 4 square plus 3 square, so that is 25 plus 16 plus 9, so that is root 50, or you can write that as 5 root 2 also by splitting it as 25 into 2. Okay, so that is the magnitude of a plus b. Okay. So now we know that for any given vector, the direction cosines, okay, the direction cosines are such that the angle with the x-axis is such that cos alpha is x component divided by magnitude. Cos beta with respect to y-axis is y component divided by magnitude, and gamma with respect to the z-axis is such that cos gamma is z component divided by magnitude. Okay, so these are the individual angles. So here alpha is the angle with respect to x-axis. Similarly, beta is with respect to y-axis. Gamma is with respect to z-axis. So you can see that cos alpha is 1 by root, or alpha is cos inverse 1 by root, which by the way you know is 45 degrees, or pi by 4. So the answer is wrong, is it? Let me check. Answer is given as what? B, no? Answer is given as B, so sahi to hai. This thing, this is equal to 5 by root. That's how it reduces to that. So this is correct. It's just given in a different form. So it is just that it's not given directly as 45 or pi by 4. It is given in this form. So sometimes you have to be careful with the option. Okay, you might have solved it further than the option is given. So hope this is clear now, people. Right? Okay, so Shravani, hope this question is clear because you had asked it. Now moving on to question 9, which quite a few people have asked. So question 9 is now very similar to this one, the second or third question we discussed. In question 9, if you have finished writing this down, start question 9. In question 9, use dot product to find angle. You can do that. That will be one way of solving this. Very easy. Use this, that cos theta is A dot B divided by E. Use this and try and get the answer. You try to do question 9 yourself, people, it's quite easy. Incidentally, question 9 you can also do by just drawing the vectors because they are 2 dimensional. But now I want you to see that this is the even easier method. Even for 2D vectors, this is the easier method of finding the angle rather than drawing them and all that. Yes, Durgesh, I will come to question 30. Just give me a moment here. we will come in serial order. Let's finish 9, and I think somebody has a doubt in question 11 also. Then we'll have to come to question. Okay. So question 9, let's look at that next. So question 9, vector E is given to us as 12 y cap plus 16 j cap, and vector B is given to us as 7 j cap. So actually we can directly see here that the angle will be 37. Okay, but the thing is, even if you can't see that, you have the dot product method. Why you can directly see the angle here is because it's in the xy plane, so you can visualize the vectors. You don't need to do any calculation. You can visualize the vectors and see that the vector E, for example, here will be like this. E will be such that its magnitude, you can see, is going to be 20, but this angle is going to be 53 degrees. You can see that, because you can see that for E, theta is tan inverse, or let's say theta A or whatever, with respect to the x-axis is tan inverse 16 by 12 or 4 by 3. So that's 53. And the vector B is very simple. It's directly along the y-axis. That's why it's even more meaningless, this method. But one vector is given directly along the y-axis. So now this angle, the angle between them, that is nothing but 90 minus 50. So theta you can see is 30. That's one way. Okay, or we can also use the dot product method, that cos theta is equal to A dot B divided by AB. So A dot B यहाँ कितना हो जाएगा? 12 into 7, 84, and mod A will be root of 12 square plus 16 square, and mod B is 7. So it's nothing but 12 upon 20. That is nothing but cos theta is 3 by 5 means theta is, oh sorry, this is 16 into 5. So this will become, it's the product of the y components. This will become 4 by 5. So theta is, so this is the dot product. Okay, so just finish going through the 9th question if required. Okay. Next up on our list, we have, I think, the 11th question, then the 13th question. Oh no, sorry, not 11th question. We have 12th question, then 13th, and then 14th. Oh, 10th also. Okay, okay. So we'll do 10th, 12th, the order in which we go next. Okay, Shikhar, we will discuss 10th question. But you can do it by triangle law also. Or you can do by component algebra also. So you two separate methods of doing question 10. So question 10, it is given to us that E plus B is perpendicular to E and has magnitude of 3/4 on the magnitude of it. Okay, this is what is given to us. So we have to find mod A is to mod B. So one is we can do it by triangle law. So if we draw the vector triangle, you realize that whatever A is, B will have to be something like this. That's the only way the resultant of A and B can become perpendicular to A. So the angle between them has to be an obtuse angle. And only in that case, we can have this equation where this is okay. So this is the resultant A plus. Now it is also given to us that magnitude of A plus B is equal to 3/4 of magnitude of A. So that means if magnitude of A is suppose x, then magnitude of A plus B is 3/4x. Okay. So in this triangle, if this is x, this is 3/4x. Then what about magnitude of B? By Pythagoras theorem, magnitude of B will become square root of x square plus 3/4x whole square. So it will become 5/4x. So you see that when you solve this, it becomes 5/4x. Okay. So now that will tell you that mod A is to mod B equal to x is to 5/4x or 4 is to 5. So this is the triangle law method of solving the 10th question. Yeah, Pythagoras theorem only. Ultimately, I made use of Pythagoras theorem. Now, second method, we can also use component algebra. Okay. So this thing that we said that okay, A and A plus B are perpendicular to each other. So let us say this is the vector A, and perpendicular to it is the vector A plus B. And this is some, let's say, small a in magnitude. So this is 3/4 a in magnitude. So what I'll now do is, let's take this as our x-axis and this as our y-axis. So in component form, the vector A is A I cap, and the vector B is, sorry, the vector A plus B is 3/4 E. So equation 1, equation 2. Now subtract the two equations. So 2 minus 1 will tell us that the vector B is minus AI cap plus 3/4 E. So that will tell me that the magnitude of B is root of E square plus 3a/4 whole square. That is 5a/4. So that will again tell you the same. Therefore, mod A is to mod B. E is to 5a/4. So this is how we can use the I cap J cap notation component algebra to solve the same. One was we use the triangles property, that is a right angle triangle, and use Pythagoras theorem. The other is that we can make use of component algebra. So this is the second one. So this was 10th question. Okay, next we come to 12th question. Let's go through it. Alright, people, so this is clear. Now let's come to 12th question in the integer answer type. Yeah, I can. So we move back to method 1 for a moment. Just go through it. Done. Okay, so let's come to the 12th question now. Okay, thank you. So 12th question, it is given to us that magnitude of A is 5, magnitude of B is 4, and the dot product of A and B is minus 20. And we've been asked to find the magnitude of their resultant. This is the next. So you use this information. So from this, you get that A dot B is equal to AB cos theta is equal to minus 20. So now use the values given to us. So you can see that 5 into 4 into cos theta is minus 20, which means that cos theta is minus 1, which means that theta is how much? 180 degrees. So they are opposite in direction. So therefore you know that mod of A plus B will just become the difference of their magnitudes. That's all. It will be 1. Or you can use triangle law. You don't remember this directly, that whenever theta is 180, this happens. Just use this. Cos 180 is minus 1, so that becomes B minus B whole square plus square. Nothing but mod of. Okay. Or you understand diagram wise that B is like this, suppose of magnitude 4, then B is exactly opposite in direction. So B would be like this. But at 180 degrees. So A plus B would have a magnitude of 1. This would become the result. So this is question number 12. So finish this and let's move on to question 13 next. Okay, so let's move on to question 13. So 13 is an interesting type of application. You have to make use of three-dimensional vector application because it says that F1 and F2 are in the horizontal plane such that the angle between them is 60 degrees. Okay. And their magnitudes are I think equal, right? 4 Newton. And magnitude of F1 is equal to magnitude of F2 is equal to 4 newtons. F3 is vertical. So that means it is perpendicular to the horizontal plane. The fact that it is given to you as a vertical force, that means it is perpendicular to the horizontal plane and also of magnitude 4 newtons. So we have to find mod of F1 plus F2 plus F3. What we have to calculate now. So what we'll have to do is we'll have to make use of a 3-dimensional coordinate system. So construct a XYZ system such that XY plane is the horizontal and Z axis is vertical. So basically, we are looking at constructing some kind of a plane where 3-dimensionally we think about drawing it, be something like this. Suppose this is a horizontal surface. This is a horizontal plane and perpendicular to it like this. This is the vertical direction. So gravity would be acting like this. Yeah, I'll explain. We'll go back to the language of the question and we understand. So यहाँ पे मैं XY axis ऐसे draw करूँ. ये जो है कहाँ lie कर रहा है horizontal plane. So this is my XY system. And perpendicular to this will become my Z axis. Okay. Because see, one of the forces F3 is along the Z axis, along the vertical. So we have to use the Z axis. So this is that. So what will happen is, suppose F1 is along X axis. Then that means F2 will be in XY plane at 60 degrees to X axis. So that means if we straight away look into the XY plane, in that diagram we can understand how F1 and F2 are looking like vectors. And we don't need to see the Z axis in this diagram because we're only looking at these two forces F1 and F2. इसमें क्या होगा कि अगर F1 ऐसा है, that is along the positive X axis. Suppose it could be along the Y axis, but it doesn't matter. Ultimately, we have to only find magnitude. F1 is a force like this of 4 newtons. Then F2 will have to be a force which is at 60 degrees to it. So F2 will have to be something like this. It could be like this or it could be like this also. It doesn't matter. Ultimately, you have to only calculate magnitude of the sum, so that will not matter whether we take the angle in this direction as 60 degrees or that direction. So if I take like this anyway, so then F1 will be written as 4 I cap. But what about F2? It will be written as 4 cos 60, so that is 2, plus 4 sin 60, so that is 2. Because this one will have an x component of F2 cos 60. This one will have a y component of F2 sin 60. Okay, so these are the forces. Okay. But in comparison to these two forces, what about this one? Where will the F3 lie? F3 will lie vertically. F3 will lie in this diagram like this. F3 is the force which is like this. Whereas F1 and F2 we just saw the forces which were lying in the organ. Yeah, so what about F3 now? F3 will be just 4 k cap. So directly we can write F3. Because it's a vertical force. Okay. Whereas these two are lying in the horizontal. J cap limit, K cap. These two are in the horizontal plane. They are lying in the xy plane. But F3 कहाँ पे है? ये diagram में it is coming out of the plane. It is perpendicular to the plane of the diagram. So it is 4 k cap. Or in the above diagram, you can see it's like this. F3 is along the z axis. So 4 k cap. Shikhar, is it clear now? So now we can see that these are my vectors in component form. So F1 plus F2 plus F3. The vector sum क्या हो जाएगा? 4 plus 2 along the x-axis. Okay. Then 2 root 3 along the y-axis. And again 4 along the z-axis. Okay. Yeah, let me just check the answer. So magnitude of F1 plus F2 plus F3 is nothing but now mod of this vector. It is mod of 6 I cap plus 2 3 j cap plus 4 k cap. So that is nothing but square root of 6 square plus 2 root 3 ka whole square plus 4 square. So that is 36 plus 4 into 3. So that's 12 plus 16. That is square root of 36 plus 12 plus 16. So that will become how much now? 36 plus 24. That is how much? Square root of 16. Okay. So magnitude of F1 plus F2 plus F3. Is it? Oh, sorry. 64. Right. 18 plus and 28 plus 36. So 64. That is becoming 8. 8 newtons. The result is 9. All right, so this is a typical question where you understand the importance of 3D vectors. अगर मेरे पास I cap, J cap, K cap rotation नहीं होता, then मैं ये resultant निकाल ही नहीं सकता because we cannot draw it in a two-dimensional plane and understand. Okay, so hope this is fully clear. This was the 13th question. We will also discuss the 14th question. We'll come to that. Okay, so let's quickly discuss the 14th question as the last one for this one. So it's given to us that the vector resultant of A and B, that is A plus B, is perpendicular to the difference of A and B. And magnitude of A is given. From that we have to find magnitude of B. So there are quite a few ways of doing this question. So given that A plus B as a vector is perpendicular to A minus B, and mod A is I think 5 or whatever, so we have to find mod B. So anybody got an idea how to do this? One is that we can use dot product. Dot product of perpendicular vectors is how much? Is 0. So we can use this fact. That is, if C dot D, let's say 2 vectors is 0, that means C is perpendicular to B. Any 2 vectors, right? So let us say C is the vector which is A plus B, and D is the vector which is A minus B. Then that means over here that A plus B dot product with A minus B should be 0. So that means that now open this by distributive property. So this will become A dot A minus A dot B plus B dot A minus B dot B is equal to 0. Now we'll use 2 important properties of dot product. That is, A dot A is equal to magnitude of A square, and A dot B is the same thing as B dot A. So that is why next step this sum will become 0. So we've used 2 properties here. One is that we've used A dot B is equal to B dot B. So for this step, and we've used the fact that A dot A is square of its magnitude, or B dot B, any vector dot product with itself is square of its magnitude. So we made use of these 2. That's how we're getting this. So finally what we get is that A square minus B square is 0. That means B is equal to, in general, plus or minus of A, but here we take only positive because B is magnitude of a vector. So it is a non-negative quantity, as is E. So magnitude of B will become equal to magnitude of E is equal to 5. So that is the one of the 3 methods of solving this problem using the dot product concept. But when you use the dot product, in this case, we are also using properties of the dot product, namely distributive property. Here, from here to here, we solve by using distributive property. That is, A dot of B plus C is equal to A dot B plus A dot C. That kind of thing we use. And here we have used what is called the commutative property. And there is another property that dot product with self is square of the magnitude. So we are using some special aspects of the dot product to solve this. Yeah, this is only method one. This is the first method. The dot product of two vectors is 0 and they are perpendicular. This is okay. So if you understood this method, try out the second method now, which will be we will use component algebra. So hope all of you are clear with this method. Right. So next we'll use component algebra method. E plus B is perpendicular to E minus B. This is the statement given to us in the question. So if we assume that our x-axis is along A plus B, so you can write A plus B as some unknown magnitude x but along the x-axis, then it implies that E minus B must be perpendicular to it. We can say that okay, E minus B is yg. So write this as equation 1 and equation 2, and now do this simple operation that equation 1 plus 2 will give us 2a is equal to xi cap plus yj cap, whereas equation 1 minus equation 2 will give us 2b is equal to xi cap minus yj. Now use these to show that mod a is equal to mod b. So this is the second method. Try and complete this yourself. Just minimizing this so that you can see the whole thing. So this is a clever way we can make use of components. All I'm saying is that you assume that we have taken our x-axis along A plus B, and E minus B is therefore along the y-axis in our two-dimensional plane. So the moment I make that assumption, then in terms of the unknown quantities x and y, I can express E plus B as xi cap and E minus B as yj cap. And therefore, I can compare the vector E with the vector B in terms of the two unknown quantities x and y. And from that, I can prove very easily that what is the relationship between their magnitudes is in fact that they are same. So just try and complete this proof yourself. Okay, people, so hope this is clear. Done. Just a moment, I will reshare the screen. Just need to reboot the program once. Just a moment. Yeah. So here it comes. Okay. So from this, you can see quite easily that magnitude of vector, or rather, first of all, you will get vector E itself. Solve this. From these equations, we will first of all be able to show that vector E is x by 2 I cap plus y by 2 j cap. So it has a magnitude of root of x square plus y square by 4. Okay. And vector B is x by 2 I cap minus y by 2 j cap. So though it's a different vector, but it still has the same magnitude. So that shows this, and that is equal to 5 because mod A was given to us as 5. So that's the second method. Okay. Doing this. Now the third method is, I'll give you a interesting hint. So method 3 is make use of the vector parallelogram formed by vectors A and B. That parallelogram is such a parallelogram whose diagonals should be perpendicular to each other, because the diagonals only represent the sum and difference. If we consider any two arbitrary vectors A and B like this, and we construct a parallelogram using them, then we know that that parallelogram contains the two triangles which represent the sum and the difference. So we can see that if we were to consider the sum wala triangle, that would have been a triangle like this. And this would have been the sum. So that sum is contained over here. It is this diagonal. So A plus B becomes this particular diagonal of the parallelogram. And this triangle is nothing but this particular triangle here. This angle is alpha, so this angle becomes alpha. And this exterior angle is theta, so here you can see this angle is also theta. This is vector E and this is vector B. Okay. And likewise, if you consider the second diagonal, this one, it represents the difference of A and B. So this is A minus B, because similarly, if you were to construct the difference of the two vectors using a triangle, you would first construct the vector E, and then you would add to that the vector minus B. So that would look something like this. So this vector E, this vector minus B, such that this angle here is 180 minus theta, and this vector here is A minus B. So this triangle that you are seeing here is contained within the parallelogram here, this particular, because this angle is 180 minus theta. You can see that. So geometrically, you will understand here that if we say A plus B is perpendicular to A minus B, that automatically implies that the diagonals are perpendicular in the parallelogram. So we know that whenever the diagonals are perpendicular, the the particular parallelogram by definition has to be a rhombus. So a parallelogram with perpendicular diagonals is definitely a rhombus, that is equal sides. That means mod A is equal to mod B, which was given as 5. So this is the geometrical solution of the same thing. Okay, we understand that geometrically what are the diagonals? They are the sum and difference of the vectors A and B, which are used to construct the parallelogram. And geometrically we also understand that in what conditions the diagonals of a parallelogram will be perpendicular, only when that parallelogram in particular is a rhombus. Okay. So this is yet another way of understanding the same question, but now understanding it geometrically. Okay. So this is another nice little trick you can remember, that since the sum and the difference are the diagonals of the parallelogram, so if there is some special relationship between the sum and difference, that gives you a special case of the parallelogram. So that special relationship is that they are perpendicular. That gives you the relationship that diagonals of the parallelogram are perpendicular. That means the parallelogram is a rhombus. So rhombus has the property that the sides are equal. So in this case, the sides are nothing but A and B. So vectors A and B must be by definition of equal magnitude. Okay, people. So with that, we complete the discussion of the worksheet. Now we'll continue ahead with some more aspects of the dot product we'll understand today. Very important, so that we can do applications of dot product more easily now. Okay. So we'll look further into interpretation, first of all, of scalar or dot product. But what exactly the operation gives us? Because many of you were thinking of this last time itself when we discussed the definition, that why do we use cos theta? What is the significance of that? So let us understand that now. So E dot B is equal to EB cos theta. So notice geometrically, you notice that if you draw the vectors A and B, assuming a situation where there is some kind of an acute angle between them. So if this is the vector E, and suppose this is the vector B, and the angle between them is theta. So now you can see what is the quantity B cos theta. If you drop a perpendicular here, then this quantity here is nothing but B cos theta. Okay. And similarly, if you were to take a perpendicular axis to A and drop a perpendicular on that, that would be B sin theta. But we are more interested in B cos theta. So you can also interpret this. So understand from this that B cos theta is nothing but the component, or you can say projection, of the vector B, but in which direction? In A's direction. So you can say along or parallel to A. Therefore, the interpretation becomes that E dot B, which is EB cos theta, is equal to magnitude of the vector A multiplied with the component of the vector B along. So it is nothing but magnitude of A multiplied by B cos theta. So this becomes the interpretation, that why we take B cos theta when we multiply with A, because we want to multiply the vector A's magnitude with the component of B which is along the vector. So just make a note of this point and understand this first. Okay, so through this we'll understand another aspect now, that because A dot B is interpretation wise what it gives us. It gives us a quantity which is the magnitude of one vector multiplied by the component of the second vector along this one. अरे इसीलिए लेते हैं ना b cos theta, so that we get this component of b along A. Okay. The reason why we take cos theta in the dot product is so that then we are getting one vector's magnitude multiplied by the second vector's cos component, which is nothing but the component of that vector along the first one. That's the way to understand this. Okay, Pratnesh. If we hadn't taken the cos theta, it would just be magnitude of A into magnitude of B. But we don't want that. In the dot product, that interpretation that we want is कि पहले वेक्टर के मैग्नीट्यूड को हम किस चीज से मल्टीप्लाई कर रहे हैं, सेकंड के कंपोनेंट से, the component of the second vector along the first one. That is why we take cos theta. Okay, Pratnesh and Somarup, is this clear now? Okay, good. So it is, it's more like that is the reason why we take the definition as cos theta, because we want to find out the product of the first vector's magnitude with the second vector's component along the first one. That's right. Okay. So that is why, in fact, you can see that if two vectors are perpendicular to each other, their dot product is 0. We take this case, then logically why is dot product 0? Because the component of the vector B along the vector A is not there, it's 0, doesn't have a component. Okay. Or for that matter, that is why if the angle between them is obtuse, then what will happen? Dot product will become a negative quantity, because the second vector's component along the first one will be a negative quantity. You have theta greater than 90, and you can see that the component of B along A will be a negative quantity. This B cos theta, negative quantity compared to. So that is why we get negative value. Because what is the interpretation of dot product? It is the first vector's magnitude multiplied by the second's component along the first. So if they are perpendicular, then this component only becomes 0. So dot product becomes 0. If they are having obtuse angle, then this component becomes a negative quantity. So automatically the dot product becomes negative. Okay. So now the next thing we'll see, very important point, is that dot product or scalar product can therefore be used to find the component of a given vector, say B, along another given vector, say E, okay, or perpendicular to it. Okay. So this becomes an important application of dot product. Next we'll see, using dot product, how to find the component of B parallel to it and perpendicular to E. Both of these are okay. So again, taking a generic kind of diagram, suppose this is some vector E and this is some vector b, which are given to us in I cap j cap notation. So A and B are known vectors, but in component form. Okay. And we want to find that is component of B along the vector E. So we are calling that B parallel and B perpendicular, say, which is the component of B perpendicular to E. We want to find these two components. Okay. So what we'll do is we'll make use of dot product. Okay. So from B, if we drop a perpendicular on E, we can see that this quantity here is the parallel component. So it is nothing but B cos theta. And therefore, this component, which is perpendicular to it, yeah, so Anay, it's okay if you got disconnected because you will get the recording of this. Okay. So we are just understanding how to use dot product to find these two things. The component of one vector. Okay, so just read this part, you'll understand what we do. So A and B are known in component form, and we want to find these two things: the component of B along the vector A, which we are calling B parallel, and the component of B perpendicular to the vector A, which we are calling B perpendicular. Like this. Okay, so we want to find out this. As you can see, B perpendicular is nothing but B sine theta. Okay. So how to find this? Okay. So now comes the formula for finding this. So we use the fact that E dot B is equal to EB cos theta. So we invert this formula, we can say that therefore the parallel component of B, which is nothing but B cos theta, can be written as nothing but E dot B divided by the magnitude of B. Okay. So if two vectors are known to be in component form, it's very easy to find E dot B, and it's very easy to find mod A. So then I know that okay, the component of B which is parallel, which is nothing but B cos theta, is nothing but E dot B divided by vector A's magnitude. Okay. And similarly, and for the perpendicular component, which is B sine theta, okay, use the identity that B parallel square plus B perpendicular square will be equal to B square. Why? Because cos square theta plus sine square theta is 1. Okay. Because B parallel is cos square and B perpendicular square will be sine square. So sine square plus cos square is unity, so that's why it will be equal to B square. So therefore, B perpendicular will become nothing but square root of, yes, or Pythagoras theorem. That's correct. So Muru, that's the same thing. Making use of Pythagoras theorem. So we can use this. So once we have found out the parallel component using dot product, which was this formula, we can substitute that in the lower formula and find the perpendicular component. So these two formulae give us the two quantities that we are looking for. That is the component of B parallel to the vector A and the component of B perpendicular to the vector A. Both these things can be calculated using these formulae. Okay. So just make a note of this, and we will next look at numerical questions which have the application of this. Okay, so scalar product can be used to find the component of a vector along another given vector. And then using that and Pythagoras theorem, or using that and the identity I told you, you can also use, we can also find the perpendicular component, not only the parallel component, but the perpendicular component also. So this is the method and how to find the component of B parallel to it and the component of B perpendicular to it. This. First of all, you understand what are these components. So if A and B are two vectors which are non-collinear, then from B's head, if you drop a perpendicular on E, the projection that it draws, that is the parallel component. And therefore, the perpendicular one is the perpendicular component. Yeah, I'll come down. Just waiting for everybody to finish writing this part down. Then we. So if you finish with the heading part, people, now we can see the main working part. Okay. But this is the first part. This is how we calculate the parallel component, this one. And then below that, we'll see how to calculate the perpendicular component. Okay, we are clear with this. Yeah, then I'll scroll down a bit. So, are you all clear with the first thing, that how we calculate the parallel component using the dot product? Okay. Now, from that, how do we calculate the second component, that is this perpendicular one? ये तो आ गया by using the dot product. Now, how we find the second one? You can see the relationship between the vector B itself and the two components is that they form a right angle triangle. This is a right angle triangle. So, because in this figure you can see this angle is 90, this angle is 90. So in this right angle triangle, if you use Pythagoras theorem, or like I said, you use the identity that sine square theta plus cos square theta is unity. You can see for the perpendicular component, we will make use of this. So this is how we find the perpendicular component. B sin theta निकालना है अपने को और B cos theta पता है. So just use the identity that sine square theta plus cos square theta is unity. See, Shikhar, what is B perpendicular? It is B sin theta. And what is B parallel? It's B cos theta. So square and add these two, what you will get? You will get B square cos square plus B square sin square. And cos square plus sin square is 1. So what will you get on that side? B square. Okay. And that's the same thing as Pythagoras theorem, because you can see that the parallel and perpendicular components are nothing but the base and the perpendicular of that triangle. And B is nothing but the hypotenuse. So that's another way you can understand this identity. There's also from Pythagoras theorem. This is like the base of that triangle, this is the perpendicular of that triangle, and this is the hypotenuse. Yes, exactly. We first need to calculate the parallel component, Tanishq, and then we need to substitute that in this formula so that we can find the perpendicular component. Okay. So let's do an example problem to understand this in more detail. So let's first start with an example which is two-dimensional. So I have the vector E, which is 2 root 3 I cap plus 2 j cap. I have the vector B, which is I cap plus root 3 j cap. Now find B parallel, that is the component of the vector B along the vector B, and B perpendicular, component of vector B perpendicular to vector B. Just try this out, people. Just use the formulae and concepts that we've just written above, which you would have written down, to just work out this question. Now the interesting thing about this question is that the two vectors I have given are in 2D plane. So we can also justify our answers later by drawing a diagram and understanding the geometry. Solve it by the method I'll give you, but later we'll also justify it by the geometrical method. Just try this out, people. Yes, people, anybody got the answers? Just checking the messages. The parallel component is 2. No. Yeah, Vaishnavi, your answer is correct. Tanish, correct. Good. Ritika, you have to get the answers as magnitudes. No? Remember, it is just B cos theta and B sin theta. So what you have to understand here is that supposing this is my vector A and this is my vector B. And first of all, what I'm trying to do here, let's understand that. I'm trying to find out this component as a component parallel to A. So that is B parallel. And I'm trying to find out this component as a component perpendicular to A. So therefore, naturally, if the angle between A and B is theta, then the parallel component is B cos theta. Now to calculate B cos theta, I use this trick that it is A dot B divided by mod A. So let's go back up and understand what the values are so that we can calculate A dot B. So यहाँ से देखो A dot B कितना होगा? A dot B is AX BX plus AY BY in this case because they are two dimensional vectors only. So no Z component. So it's 2 root 3 plus 2 root 3. So it is 4 root 3. Okay. And mod A कितना है? It is square root of 2 root 3 का whole square plus 2 square. So it is 4. Correct. So this becomes how much? This becomes 4 root 3 divided by 4. Or it becomes root 3. And then the next thing. So this is the first thing. This was the first formula. And then B perpendicular के लिए क्या करते थे? We used to do this. So just substitute that. Yes, Ritika, that is correct. The answer is correct. It will be 1. Okay. So that will be square root of. Now you can see here that magnitude of B कितना है? Magnitude of B is square root of 1 square plus root 3 का square. So that is 2. So यहाँ पे कितना हो जाएगा? 2 square minus root 3 का whole square. So that is. Okay. So basically, where this formula is coming from, it is coming from the fact that B perpendicular is B sin theta, which can always be written as square root of B square 1 minus cos square theta. So it can always be written as B square minus B parallel. So that's how this formula is coming. Okay, so hope the values are clear by formula method to all of you. इसका बेटा फिजिक्स में बाद में बहुत एप्लीकेशन आ सकते हैं, so that is why we do. So for example, you will see that when we study cycloidal motion in kinematics part 2 you might be studying, or later when we study circular motion, and from circular motion we study curved motion. So let's say a particle is moving along some kind of path like this. तो किसी भी इंस्टेंट पे उसका जो वेलोसिटी वेक्टर है और उसका एक्सेलरेशन वेक्टर है, they are not going to be along the same direction. And often to understand the path, we want to calculate the component of acceleration which is perpendicular, which is in fact called centripetal acceleration, and the component of acceleration which is parallel to velocity, which is called tangential acceleration. So to calculate that, we need to find the component of A parallel to B and the component of A perpendicular to B. So then we can use a method like this. Okay. So in various aspects in physics, later we'll see that there are applications of this concept. Just like there is application of dot product to find something like work done by a force. Like that, there is application of this concept also to find various different things. Okay. Now let us also see geometrically how this question is working out, because it is a two-dimensional question. So we have the option of geometry also. Okay. So also geometrically we can see, okay, because it's 2D. Okay. So the vector E was how much? It was 2 root 3 I cap plus 2 j cap. So ये कैसा दिखेगा? It will be magnitude of 4 at 30 degrees with respect to x-axis. because tan theta for this will be 1 by root 3. And similarly, vector B, which is I cap plus root 3 j cap. This is what kind of property? It is magnitude 2 at 60 degrees with respect to x-axis. So this के लिए tan theta कितना है? root 3. Okay. So if I were to draw the two vectors A and B using this property, I mean using this situation that we just learned over here, what we would see is that the vector E is suppose a vector like this. It's a vector is at an angle 30 degrees with respect to the x-axis. Okay. But in comparison, how is the vector B? It's a vector like this. जिसका कि खुद का मैग्नीट्यूड कितना है? 2 है, बट खुद का एंगल विद द एक्स एक्सिस कितना है? 60 डिग्रीज है. ये एंगल 60 डिग्रीज. तो देखो उनके बीच में जो एंगल है वो कितना है? दैट इज 30 डिग्रीज. यू कैन सी दिस एंगल विल बी 30 डिग्रीज. ओके, सो देयरफॉर द कंपोनेंट ऑफ बी अलोंग द वेक्टर ई will be this component, will be this line. So this is my B parallel, and perpendicular to A will be this one. So this will be my B perpendicular. Okay. So you can see now that in my diagram, B parallel should come out to be 2 cos 30. So it should come out to be root 3, which we have got, and B perpendicular should come out to be 2 sin 30, which is 1, which is what we got. So what it is giving us by dot product method is very accurate. Ananya, in this case, we can't get the answer directly by looking at the coefficients of I cap and j cap, okay. But we can get it by the dot product method. The components are magnitudes in this case. They are expressed as a magnitude. Okay, so these components here, this B parallel and B perpendicular, are expressed as magnitudes. And their direction is shown in the diagram. Okay, that one is along A and one is perpendicular to A. This last step, यहाँ पे देखो बेटा, ये वेक्टर B का मैग्नीट्यूड 2 है और ये एंगल 30 है. सो ये बेस कितना हो जाएगा? 2 cos 30, और ये परपेंडिकुलर कितना हो जाएगा? 2 sin 30. Just using trigonometry. Understood, Shigan? Now, Rahil, just to answer your question, we can also express them as vectors, but that's the next step. You'll see that later. Okay. Right now, we are seeing how to express them just as their magnitudes. Yes, like that we can find the component of A along B also. Okay. So, for example, if I wanted to find out here, if I said find A parallel, उसका मतलब क्या होता है? This was the vector E. Okay. This was the vector B. In fact, A was longer than B, but it doesn't matter. I would want to find out this quantity. A parallel का मतलब क्या होता है? First of all, let's understand that. So from A, you're dropping a perpendicular along B's direction. That is this direction. So this component of E would be the one which is parallel to B, and this other component would be the one which is perpendicular. So if this angle is theta, you can see that E parallel would be E cos theta. Okay, so that is again the component of E along B, and E perpendicular would be similarly, sorry, E perpendicular would be E sin theta. So this would come by doing this E dot B divided by mod B this time, okay? And this would come by doing this root of a square minus b parallel square. We can just interchange the role of a and b. That can only be done. Is that clear, Tanish? Okay. Now let us understand this in context of a 3D type question, okay, where we cannot draw the diagram, so we have to rely on the dot product method. So let's do another example because this is quite tricky in terms of numerical also. So let's take an example where the vector E is 2i cap plus 2j cap and the vector B is I cap plus j cap plus k cap. Now find this, that is the component of B along the vector E in magnitude. Just in magnitude form like we have learned. We haven't learned in component form yet or in vector form yet. So component of B perpendicular to E, and again only in magnitude form. So same steps, but this time you can see there are 3-dimensional vectors. So we will not be able to do the problem by the second method. We won't be able to use geometry because there's no way we can draw the diagram and understand what exactly is happening. Okay? We have to rely on the dot product method. Yes, that is correct, Somaru. The parallel component is correct, Somaru. Yes, Ankita correct. Rahil correct. Priyank correct. Varin Guru correct. Vaishnavi correct. Magnitude form means we are just expressing it as a value, not in I cap j cap form. We are just expressing it like we have done over here. It's just a value like root 3 or 1. It's not given in a vector form with I cap and j cap. So that's why. That is the meaning of it in magnitude form. Okay. So again, we can see that the parallel component is this. So E dot B, you will see there will become 4, whereas mod A was 2 root 2. So this is 2 by root 2, or better stated. So the parallel component of B is whereas the perpendicular component, the square root of B square minus B parallel square. Now magnitude of B you would have seen is root 3, okay? Because remember that E was the vector 2i cap plus 2j cap, and B was the vector I cap plus j cap plus k cap. So E dot B was 2 plus 2 plus 0, so that's 4, and mod A was root of 2 square plus 2 square, that is 2 root 2, and mod B is similarly square root of 1 square plus 1 square plus 1 square, so root 3. So yes, correct. substitute this, so you get this as 3 minus 2 or 1. The parallel and perpendicular components are root 2 and 1 respectively. Okay, so hope the steps are clear to all of you. Okay. So if you ever get confused in this formula, whether you want A in the denominator or B or whatever, just start by writing it out as a dot product formula. A dot B क्या है? AB cos theta. And if I'm talking about B's per parallel component, I'm talking about B cos theta. So it should be A dot B divided by mod A. Whereas if I was talking about A's per parallel component, that would be A cos theta. So that would be A dot B divided by mod B. Okay. So that way you'll never confuse what you're trying to do. Okay, now just a couple of more things I want to discuss before we wind up today's class. Okay. So just like in today's lecture, we have seen 2 or 3 important like theorem kind of things. Okay. We have seen that perpendicular condition for 2 vectors is that A dot B is 0. We have seen that the angle between 2 vectors, the easy way to find when the vectors are given in component form, it is cos inverse of A dot B divided by B. Okay. These kind of things we've seen earlier today. Now like that we'll also see condition for 2 vectors, let's say A and B, to be parallel or anti-parallel. So let us first visualize the case of 2 vectors which are parallel. So A is a vector like this and B is another vector which is parallel to it. So they should look something like this. Then if A and B are parallel, then their unit vectors should be same, or in other words identical. So what do we mean by this? Let's see. Okay. So E cap is equal to B cap. Now what is A cap? It is a unit vector along the direction of B. So A cap is this. It's a vector of magnitude 1 but which is along A, and B cap similarly is a vector of magnitude 1 along B. And if they are parallel to each other, then this unit vector is the same as this. Okay. So what we mean by this statement is that A cap, it is the unit vector along the vector E. So in other words, A cap is nothing but the vector A divided by its own magnitude. And similarly, B cap is nothing but the unit vector along the vector B. So that is nothing but B cap, which we can calculate by dividing B by its own magnitude. Now suppose A and B are 2 vectors which are mutually parallel. That means their unit vector should be identical. So that means A cap should be equal to B cap. So just write this down first, then we'll understand more about this. So whenever 2 vectors are equal, remember their unit vectors become identical. So that means A cap becomes equal to B cap. Now what is the definition of A cap? It is a vector of magnitude 1 or a unit vector which is along the vector E. So it is nothing but vector A divided by its own magnitude. Similarly, B cap is vector B divided by its own magnitude. Yeah, but above is just the heading. Okay. Condition for A and B to be parallel or anti-parallel. So we are starting with parallel vectors. That you've written down earlier, na beta? That you written down earlier. This formula you written down earlier. Don't worry about this formula just now. It is there in your notes earlier. This just I'm listing out a couple of theorems that we learned. Okay. What is the new thing next we are doing? That is this. Okay, don't worry about the formula for angle. You have written down that before. Okay, now let's understand this practically how we do this, because further we can understand, we can simplify this more. Okay. E cap is equal to B cap. Okay. This implies that the vector E divided by its own magnitude is equal to the vector B divided by its own magnitude, which means that Ex I cap plus Ey j cap plus Az k cap in general, if they are three-dimensional vectors, divided by the magnitude of E is equal to similarly Bx plus By plus Bz. This whole thing divided by its magnitude. Okay. So further now you can see that if this vector is equal to this vector, that basically means that their three components are equal. So this statement means that Ex upon E is equal to Bx upon B. Along with that, Ey upon E is equal to By upon B. And finally, also Az upon E is equal to Bz upon B. Okay. And further, if you combine these three statements, it means that Ax upon Bx will be equal to Ay upon By, will be equal to Az upon Bz, which will be A upon B, which is a positive quantity because it is the ratio of two magnitudes. So this becomes the condition for parallel vectors. This is the condition for parallel vectors. That Ex upon Bx should be equal to Ay upon By, should be equal to Az upon Bz, and that common ratio should be a positive quantity, it should not be a negative quantity. So this is finally the condition that we use to check if two vectors are parallel. The ratio of their x component should be equal to the ratio of their y components, should be equal to the ratio of their z components. It's all coming from the beginning here, that A cap is equal to B cap. So A cap क्या होता है? Vector A divided by its mod. B cap क्या होता है? Vector B divided by its mod. So this is the whole vector A divided by its mod. That's equal to this whole vector divided by its mod. So now from this equation, we are getting these three individual terms by comparing the I cap term. So see, the I cap term on this side is Ax by A, on that side is Bx by B. So Ax upon A should be equal to Bx by B. Compare the J cap term, so that should be equal. So Ay upon A should be equal to By upon B. And that should be equal to the K cap term. So Az upon A should be equal to Bz upon B. Okay. And now you can see from this that Ax upon Bx is A by B. Ay upon By is A by B. And Ez by Bz is A by B. That's why these three terms should be same, and that should be equal to E by B. Okay. So now given two vectors, this is a condition which is very easy to check. Is it clear now, right? Okay, good. Okay, so that is a condition for parallel vectors, that the ratio of x component should be equal to ratio of y component, should be ratio of z components, which should be a positive quantity. Okay. Now similarly, if they are anti-parallel, it's not too different actually. If the vectors are anti-parallel, you see that one vector is like this, so the other vector has to be in the opposite direction. So this is vector E, this is vector B. Then a unit vector along E will be like this. Okay, this will be A cap, and a unit vector along B will be like this. So anti-parallel hoga. So what is the condition? The unit vector of E should be opposite to the unit vector of B. Okay. So when you solve this, vector A upon E should be equal to minus of vector B upon B. So when you expand this using that same method, whole thing divided by mod A is equal to negative of Bx plus By plus Bz. Okay, so when we solve this, we get this similar condition, but that ratio will have to become a negative quantity. So Ax upon Bx will be equal to Ey upon By, will be equal to Ez upon Bz, which will be equal to minus of E by B. So it is a negative quantity. Okay. So that becomes a condition for anti-parallel vectors. This is the condition for anti-parallel or exactly opposite vectors. Whereas if this ratio is positive, then that is the condition for parallel vectors. Okay, so this is parallel versus anti-parallel. Whereas if these ratios are not equal, then they are neither parallel nor anti-parallel. Then there are some arbitrary vectors like this and this. These two vectors will not satisfy either this condition or the above condition. Okay, people, so hope this is clear to all of you. And with this, we come to the conclusion of today's session. You will get worksheet 6, which will be about application of these things, including the applications of projections. Ananya, just do a revision of the couple of questions that we have done, and you will understand what we are saying, that we cannot use the components directly to get the parallel component and perpendicular component. Yes. Okay. Just do a revision of the two questions that we did to find which were to do with the components of one vector parallel and perpendicular to the other one, and from that you will understand why you cannot get it directly. You have to use the dot product method. Okay. So people, that's it for today's class, as I said, and I will send you the notes and the video, of course, along with the assignment also for today. So the assignment, as I told you, will be mainly to do with the application of projections and the condition for perpendicular parallel vectors and all these kind of things, and dot products in general. Okay. So just continue working on that and discuss your doubts through the week with me. That's it for today's class, people. All the best.